I laughed. I cried. Like if you cry every time. All right, guys. I want to recap yesterday. We covered 4 things yesterday.
You bet we did.
Okay, and I'm gonna review it here for you. So listen carefully. What's up?
Wow, wrecked.
Wrecked. I got destroyed by facts and logic just then.
Destroyed.
This will work. Okay. And then we're gonna cover a couple of quick examples. Okay.
You betcha.
First thing we learned yesterday was that the derivative of e to the x is e to the x. Famous example. Now, what I've drawn on the right-hand side here, maybe you can identify that. What am I drawing on the right-hand side for each one of these results? This is the chain rule version, yeah. So this is a result you got to know. Now, here's the thing. I mean, really, if you know what the chain rule is, you don't have to like memorize that because that's just the chain rule. It's one simple thing, right? So really, you know this is the chain rule extension of it. Okay, so e to the x turns into e to the x. So if you have e to the u, you get e to the u with a u prime tacked on. Okay? 5 to the x turns into 5 to the x with this multiplier. U natural log of 5. Okay, so the bigger this number is, the bigger this multiplier will be. Which I hope makes sense, right? 10 to the x is going to be steeper than 5 to the x, and natural log of 10 is bigger than natural log of 5. What would you open that for?
Here.
No zips, no noises. No. Don't do it to me, please. Okay. So, hopefully, if you know this one, this is a pretty easy extension of that. It's like, oh, it's the same thing. You just got to remember that extra little constant that gets turned on there. Okay?
Yeah.
So yesterday we proved this. You don't have to prove it every time, right? You know this is true now. You can just use that rule. Okay. And then here, natural log of x, the derivative of that is 1 over x. Great. Okay. And then how about log base 5 of x? Well, log base 5 of x is same thing, 1 over x, just then you have this extra little constant multiplied the reciprocal of the natural log of your base. Okay. And then so for each one of these, chain rule version. So if 5 to the x turns into log of 5 times 5 to the x, then 5 to the u turns into log of 5 times 5 to the u with u prime tacked on, right? Same thing. If log of x is 1 over x, then log of u turns into 1 over u with u prime tacked on, and there you go. So Feely report.
Great.
How's the Feely's report? Okay. It hopefully is not too overwhelming there. So 4 things, okay?
One of my favorite things that we do in math is when you have a formula and then you go through the math to explain why the formula is the formula. Oh, that's the best.
Yeah, proof. Yeah.
But not necessarily the long ass proofs where you have to write down the theorems. Those are boring. But the one where you just manipulate the.
Well, there's a lot of writing that's been done. In particular, there's one essay by Paul Lockhart, I think, who criticized the way that say a typical high school geometry textbook covers proof is kind of ridiculous. Because they'll do stuff like, well, if 6 equals x, then x equals 6, and I know that because of the symmetric property of equality. It's like, bruh, no one cares. No one.
Yeah, exactly.
Unless you're Bertrand Russell and you're trying to write the next proof that 1 + 1 = 2, and you're trying to get on into the deep philosophical roots of mathematics, then you probably get to the interesting part. So he uses in the essay he uses an example of where they prove that if you have 2 lines at these angles are the same size, and it's just an absurd proof. It's by symmetry. It's self-evident. Why are you proving that anyway? So I agree with you, Jesse. I feel as you.
Okay. Yeah.
Okay, so what would you do then if you had, I don't know, what's the derivative? I'll just run a couple of quick examples for you here. An example of the first one would be, let's say you had, what's the derivative of e to the x cubed plus x power? Oh, scary, right? E to the x cubed plus x power. Well, that's just e to the u. This is my u. And so I'd go,
3x squared plus
okay, u prime times e
Yep.
to the u.
Yeah.
Simple as that, right? Okay,
Thank you.
suppose you had the derivative of 7 to the x squared plus 5 power. Oh, scary again. Oh, it's not so bad. There's my u. So that's this form here. Some number to the u power. So I'd go u prime times natural log of 7 times.
7 to the x squared plus 5.
Not too bad, right? Pretty painless. And then what if you had the natural log of, let's make a weird one, x to the 5th plus the square root of x. Oh, scary. No, it's not so bad. You're going to have u prime
5x squared to the 4th plus 1 over 2 with x.
okay, times 1 over.
X. Yeah,
Yeah, do you understand that?
yep. Thank you.
Now, of course, you could put this expression on top, write it as 5x to the 4th plus 1 over 2 root x over x to the 5th plus root x. And then lastly, what if I had the derivative of log base 3 of, I don't know, x plus 2x cubed, I don't know. Same idea, you go u prime, right, times 1 over the natural log of 3 times 1 over u.
Whee!
Yeah?
Yeah.
Any questions at all?
Oh,
No.
Okay. I'll leave those up on the board. Take some time to work. Also, I mean, I guess the one thing I omitted is, yes, you still have to know the quotient rule and product rule. So you might see a question that's like, oh, I've got a 3 to the x multiplied by a natural log of x or something, and you're just going to have to apply these new derivatives that we just learned in conjunction with the product rule like we covered yesterday. So, all right.
yeah.
Thanks for the 100 bits and the pogwoos and the